Hello everyone, welcome to my YouTube channel School of Chemistry. So in continuation with my previous video, today we are going to study about the IPSC nomenclature of the compound with different functional groups in them. So for class 10th, we have 5 different type of functional group. One is the haloalkanes, second is alcohols, third is aldehydes, fourth one is ketones, and the fifth one is carboxylic acid. So these are the five different functional groups which are there in the IPC nomenclature of class 10th. So let us start the IPC nomenclature of these compounds with the first one, that is haloalkanes. So as the name suggests, haloalkanes. So in haloalkanes, halogens are attached to an alkane. Let us take an example, CH3Cl. Now one of the hydrogen is being replaced with a halogen. So halogens are always written as a prefix. Halogens are written as prefix. Okay, so what will be the different prefixes for the different halogens present over here? So for chlorine, we will be writing chloro. For bromine, we will be writing bromo. For iodine, we will be writing iodo. And for fluorine, we will be writing fluoro. So these are the different prefixes for the different halogens if they are present in any of the haloalkane. Suppose we have this compound CH3Cl. How to name this compound? So the halogen is named first, that is as a prefix. So we'll write chloro, then is the word root meth, as it consists of only one carbon atom, and next is the suffix "ane" as it has single bonding in it. So name of this compound comes out to be as chloromethane. If we have one more compound with two carbon atom like CH3 CH2Cl, then we can name it as chloroethane. As these halogens are present on the first carbon atom, we need not to specify their position, but if the halogens are present in between the chain, like a compound like this is there, okay, then we have to use the simple rules for the writing of the IPC nomenclature. That first select the longest chain. After that, we will put the numbering in this in such a way that our substituent get the lowest number. Now over here, chlorine will act as a substituent, and that will be written as a prefix. So this becomes 2-chloro, word root, prop, single bonding ane as the suffix. So the name of the compound becomes 2-chloropropane. If we have a higher carbon atom chain and we have CH3, CH2, CH, and a chlorine is present over here, CH2 and CH3, then we can again name this compound by selecting the longest chain, as it is a 5 carbon atom and the chlorine atom is present on the third carbon atom when we place the numbering on this chain. So this becomes 3-chloropentane. IPC naming of this compound would be 3-chloropentane. Fine. And sometimes the question arises in the mind of the student that if we have two halogen atoms, then what we are going to do? Let us start with the very simple compound, that is CH2Cl2. Okay, then we can write down its name as dichloroethane. methane. Dichloro is written for the two chlorine atom. Meth is written as the word root and ane as the suffix. If we have chlorine atoms present on the different carbon atom, like chlorine on the middle and at the, you can say, terminal. Okay, then we'll start the numbering from here in such a manner that the substance get the lowest number. Okay, now chlorine over here is acting as a substrate. So their positions in the chain is 1, 2. Then we'll write how many chlorines are there. There are 2 chlorine atoms. So we'll be writing di. Then chloro. And then is a word root. It will be prop. And then is the suffix is the ane. So 1, 2 dichloropropane. Fine. And if some heteroatoms come, heteroatoms where different halogens are present over there. Suppose chlorine is present at the one end, CH2, 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 and suppose a bromine is present on the other side. Then we'll put the numbering on the basis of the alphabetical order and start the numbering from the right hand side 1, 2, and 3, and write down the name of the compound as 1 bromo, 3 chloro propane. This was all about the nomenclature of haloalkanes. The second functional group which comes over here is the alcohols, which can be represented with the general formula as ROH. And we'll write down the suffix for alcohols as OL. So in class 9th, we will have simple compounds like CH3OH, and for that we can write first the word root meth, then ANE is substituted with the secondary suffix OL. So the name of the compound becomes methanol. Then if we increase the carbon content or the carbon chain, we can write down the name as ethanol. Suppose it is present in the middle of the chain, then in that case we have to write down the name of the compound as propane, then the position of the functional group 2 all. Okay, as it indicates that our functional group is present on the middle carbon atom or the second carbon atom of the chain. Suppose if we have two alcoholic groups present on an alkene chain, we can name it as first the word root eth, ANE. Now in this case, when two or more than two functional groups are present on a parent chain, okay, two or more functional groups are present on the parent chain, then we can write down the name of the compound as first the word root eth, then primary suffix in. Okay, E is not replaced over here because after that we have two functional group. We'll write the first, write down the position 1, 2, then it's diol. So the name of the compound becomes ethane 1, 2 diol. And the common name for this compound is glycol. Similarly, glycol. Similarly, we have CH2OH, CHOH, and CH2OH. For this compound, we can write it as propane 1, 2, 3 triol. So this was all about the nomenclature of the alcohol. The next functional groups comes on the way are aldehydes. Aldehydes has the general formula RCHO and the suffix we'll be using for them is Al. It's not all, it's al. A then L. Al. So the first aldehyde which we have is the HCHO, and it could be named as methanol. Then when we increase the carbon content, we can write it as CH3CHO and name the compound is ethanol. Now one thing you should keep in mind that while writing the name of the aldehyde, the carbon which is a part of the functional group should be included as a part of the parent chain. So if you have the CH3CH2CHO, we can name this compound as propanol. And if we have certain compounds like CH3CH, we have a substituent CH3 and then CH over here, we can name it as 1, 2, 3. So second carbon has a CH3 which can be written as a prefix. So 2-methyl propane 1-al. So in order to indicate the position of the aldehyde group, we can write it as 1-al. Okay, one thing that you should keep in mind is aldehydes are never placed in between the chain. They are always present at the terminal position of the chain. Next comes the ketones. Now ketones as a general formula are C double bond O R dash, where R may be equal to R dash or R may not be equal to R dash. Okay. The suffix we'll be using in the ketones is ONE. It's not one, it's own. So the smallest ketone we'll be having over here is CH3 C double bond O CH3, and we can name it as it contains 3 carbon atom, we have to write down the word root as a prop, then single bond AN, and then the secondary suffix that is 2 on. We can simply write as a propanone also, because this compound doesn't have any other carbon which can hold this ketonic group, so we can simply write it as propanone. For this compound it can be written as butanone or butane 2-on, and in that case we have to start the numbering from the left hand side, 1, 2, 3 and 4. But the compounds like we have this which doesn't have the ketonic group on the second carbon atom, in that case we have to specify the name as pentane 3-on, because this can have the ketonic group either on the second carbon or at the third carbon. So in that case we need to specify its position. So this is how we can name the ketones. And the last is the carboxylic acids. Carboxylic acids, we can write down the general formula of carboxylic acid as RCOOH, and the suffix which can be used in their cases is oic acid. So the first or the simplest carboxylic acid is HCOOH, or we can represent it like this also, HC double bond OOH. Okay, and this, the common name to this compound is the formic acid, and according to IUPAC we can name it as methanoic acid. E is being substituted with oic acid, so this becomes methanoic acid. CH3COOH can be written as ethanoic acid, and then is the CH3, CH2, COOH, which can be written as propanoic acid. Like that of aldehyde, carboxylic acid also doesn't games in between the chain. It's always present at the terminal of the carbon chain. Okay, and similarly, we can write down the name of the different carboxylic acids which are present in your syllabus. So, hope my videos are helping you in your studies. And for more interesting videos, please like and subscribe to my YouTube channel, School of Chemistry.